Okay, good day. This is Math 130 Intro to Statistics. I'm Professor McCulley. This is Lesson 25, Hypothesis Testing for the Mean when Standard Deviation is Unknown. Let's get right to it. So, today we're going to talk about finding the critical numbers in a t-distribution, which is a little bit different than the z-distribution. And we're going to use a t-test to test a mean when the standard deviation is not known. And we're going to use technology to find p-values, use them with the t-test to test the mean when the standard deviation is not known. Okay, so once again, when the standard deviation is not known, and when I say that, I'm talking about the global standard deviation. Well, we're going to have a t-distribution, which is a little bit different than the standard normal distribution. But the t-test for a mean is the statistical test for a population mean. The test statistic, again, is the sample mean. And the standardized test statistic is t equal to, and this looks very similar to the z, except here, this is our sample standard deviation instead of our global standard deviation, but we're going to take the sample mean, subtract it from the population mean, divided by the standard deviation of the sample, all over the square root of the sample size. And then we need these conditions to be met, that the sample is random and that either the population is normally distributed or that the sample size is greater than 30. And remember, when you're talking about a t-test, we're going to have to worry about the degrees of freedom, and those degrees of freedom are just the sample size minus 1. And so the process that we're going to go to find those values and to test a mean is going to be very, very similar to the ones that we did in the last lesson, except now we're going to use a t-distribution instead of a z-distribution standard. And so we got to verify that the standard deviation is not known and that the sample is random, and either that the population is normally distributed or that the sample size is greater than or equal to 30. So one of these two, but it has to be a random sample. We're going to state the claim mathematically and vertically, or verbally, not vertically. Identify the null and alternative hypothesis. You've seen that. We're going to specify the level of significance. You found that. Here's something new. We got to identify the degrees of freedom, which are just n minus 1. We're going to determine the critical values, and you do that either by a table or the inverse t. And then we're going to determine the rejection regions. We're going to find the standardized test statistic. We're going to make a decision to reject or fail to reject the null hypothesis, and then we'll interpret the decision in the context of the original claim. So none of this stuff is really new. We've done t-tests before when we were doing confidence intervals, so that's not anything new. So let's get right to it here. A car dealer says that the mean price of a 4-year-old sports utility vehicle in good condition is $18,000. This claim is suspected to be false. And so to test this claim, 20 similar vehicles were randomly selected that have in that 20 selection of 20, we have a mean price of $18,241 with a standard deviation, and this is the sample standard deviation of $1,586. If the price of 4-year-old sports utility vehicles are normally distributed, is there enough evidence to reject the claim at the 0.05 level? Okay, so what we want to do here is we want to start by going through and doing all of the steps. And so our first step here is we're going to verify that the standard deviation is not known, and we are giving S this time. The sample standard deviation is 1586. This is, remember, the sample standard deviation. And this is what really separates it from the last lesson. The fact that we have a sample standard deviation instead of a global standard deviation, that is what determines the difference between a z-test and a t-test. All right, so then the other two things, we do know that we only have an n equal to 20. That's too small. but they do say that the population is normally distributed. So now that we've done those things, we know that we are in fact using a t-test because, again, we have a normally distributed population, which is one of the two things that we had to have. And we also do not know the population standard deviation. So number two, we're going to state our hypothesis, and so we're going to say that the mean price of a 4-year-old SUV, just for time's sake, is equal to $18,000. All right, so since this is a statement of equality, our null hypothesis is going to be a mean of 18,000, and our alternative hypothesis is going to be a mean not equal to 18,000. And so that implies a two-tailed test. All right, and so since in 3 our level of significance is 0.05, we're going to divide that into two parts. For the critical numbers. All right, so here we have a t distribution, and so again we're going to have 0.025. That's the area in that one, and so that'll have a critical t, and then that one will be negative, and this will be positive TUC. And again, this area right here. Oops. Equal to 0.025. All right. So this time we have to identify degrees of freedom. Usually that's a lowercase, so let's make it. Oops, don't want to do that. Let's make this a lowercase. D period F period. That works. And that is going to be n minus 1. In this case, there are 20 minus 1, so our degrees of freedom are 19. And so this is number 4. Number 5, we want to determine our critical values. We want to figure out what these TCs are. And so we're going to use the inverse T value. And so if I grab my graphic calculator, second distribute, inverse T is right there. So I'm going to go 4 inverse T, our area. We want to be 0.25, and this is a cumulative area. And then we have a 19 for our degrees of freedom. And so when I paste that in there, I get my critical numbers of, so negative TC equal to negative 2.0903, and then my positive TC is going to be positive 2.0903. Now, again, couple ways to do this. Since we have these standardized critical numbers, if our actual test, our standardized test statistic, this TC, is in between these two values right here, we're going to fail to reject the null. And if we have extreme values that are outside either of those, we will reject the null hypothesis. All right, so those are our rejection regions. So our rejection regions will be anything that is where you have a t-value that's going to be less than negative 2.0903 or a t-value that's greater than 2.0903. And so now we're going to calculate that test statistic. All right, and so that thing was defined as t equal to the sample mean minus the proposed mean over the sample standard deviation divided by the square root of n. In this particular instance, that was $18,241 minus $18,000 all over the sample standard deviation of 1,586 over the square root of 20. And I get that calculation to be, let's see here, so alpha y equals gives me the fraction, and then it's 18,241 minus 18,000 all over alpha y equals, get me that fraction, and it's 1,586 over second square root 20, and I get this. This is my standard test statistic. So it was 0.6796. Now that's my t-score. And so clearly, if I'm using regions to make a determination, this TC right here is 2.0903. The one that we found, our t, is equal to 0.0796. So clearly that's inside that region, so we would fail to reject the null hypothesis in this particular instance. Now, we could also do it in terms of our p-value if we wanted to. And so the way that we could do that is we could make this calculation right here, and we could go second, and then we could go distribute, and we could go inverse t, or excuse me, TCDF. So I'm going to hit that 6 there, and so from negative infinity to here, it would be 0.97 degrees of freedom, or 19, paste, enter, 7.62, and that's finding this total area. Let's do red. Let's do that. That finds the area from here to there, that total area, and we don't really need all of that. But anyway, that's our test region, our region there. So 8. Oops, I don't want to do that. So 8. We're going to make a decision. Again, we are fail to reject the null hypothesis. And so finish it up by wrapping everything together, wrapping everything up together. And so there is not, oops, let's write that a little bit better here. There is not enough statistical evidence to reject the claim that 4-year-old SUVs have a mean value. It's not very good. Let's do a better job. Value of 18,000 at the 0.05 level. Now, again, we went through and we calculated all of these pieces here just to to get an idea of what goes into it. But as a practical matter, we can use the graphing calculator again and hit the stat, go over to tests, go over to test, and we do have a t-test, so we're going to hit 2, leave it on statistics. Our null mean we said was 18,000. The sample mean that we came up with was 18,241. Our sample standard deviation was 1,586. We had a sample size of 20, and we are trying to show that it is a not equal to. That is what the alternative hypothesis is. So if I come down here to calculate, it calculates all of that value in here. You can see the test statistic. You can see the p-value. You can figure out there's our samples, and so according to the 0.05 level, this clearly is something that we would still reject. Right. Moving on. Another example, a credit card company claims that the mean credit card debt for members of Generation Z is greater than $4,000. Wanting to test this claim, a researcher finds a random sample of 42 cardholders, finds that they have a mean credit card debt of $4,326 with a standard deviation of $535. At the 0.05 level, can the researcher support this claim? So again, we're given a sample standard deviation as 535. We have an n equal to 42, so we don't have to care about whether or not it's normally distributed or not. So we are good. And so number 2, it's going to ask us to state our claims. State our claims. So our claim here is credit card debt for Gen Z members is greater than $4,000. And so the null hypothesis, and just so we're clear for my alternative and null, this is greater than, so it is an inequality symbol. So we're saying that the mean, so our claim is greater than $4,000. Our claim this time is in the alternative hypothesis, where it was in the null hypothesis in the first one. So less than or equal to 4,000 would be the complement. And so 3, our level of significance is alpha equal to 5. Oops, did that wrong. Our alpha equal to 0.05. 4. We need to identify our degrees of freedom. And so in that case, n equals 42 minus 1. So df is going to, let's do this better. Our degrees of freedom are equal to n minus 1, which would be equal to 42 minus 1, which is 42. And then so for number 5, we've got to determine our critical values. And so this is a one-tailed test. In fact, it is a right-tailed test. And so in this particular instance, we're going to figure out our critical value here, get that whole value there. And so to do that, we're going to go the inverse T I N V T, and then it's so if we have a so if this is 0.05, this area here is 0.95. So we're going to go 0.95 comma our degrees of freedom, which was 41, and I screwed that up, and I suppose you guys are all laughing at me. That should be a 41 there, because 42 minus 1 is clearly 41. All right, and so let's make that calculation. So second, hit the vars button, inverse T 4, and so my area 0.95, degrees of freedom 41, paste that in there, and we get 1.6282. And so any t value that when we calculate our t value, we're going to reject anything that would be greater than this number. So in number 6, our reject region is going to be a t value that's greater than 1.6282. And so crud. Let's do a better job enumerating our list here. All right, 7. Come on, give me 7. So we're anything t value that's bigger than that, that's when we will reject it. What we'll do here is we'll say we're going to calculate our test statistic. And remember that that was a t value, and that is the mean, the sample mean minus the mean over the sample standard deviation over the square root of the number of elements. In this particular instance, it was 4.326 over 4,000. Second here, yeah, 4,000, and then the standard deviation is 535 over the square root of 42, and I have that calculated, so just for the sake of expediency here, this comes out to 3,000 or 3.9490, and that is clearly larger than our reject region. So 8, since our t here, or since our t, and this is tc, or no, it's not tc, since t equal to 3.9490 is greater than the critical number, the critical t-score of 1.6282, we're going to reject t, the null hypothesis. And finishing up by rewriting it, there is statistical evidence Okay, then so again, we got to go back here. Remember, our claim is here. And so since we are rejecting the null hypothesis, we can support the alternative hypothesis. And so there is statistical evidence at the alpha equals 0.05 level of significance to support the claim that the average credit card debt of members of Generation Z is more than $4,000. And that's all I got. So Marvel fun fact of the day: Cosmo the space dog is seen briefly in Guardians of the Galaxy. He was once a former test animal for the former Soviet Union's space race back in the 60s, and he was mutated by cosmic rays, the same things that created the Fantastic Four while he was in space, and he has the power of telepathy and telekinesis. Pretty awesome for a dog. Well, that's all I got. Have a good day. Bye.